Hello, good afternoon, everyone. Can you hear me?
Yes, can hear you, sir. Afternoon, sir.
Yes. Hi, thank you. Very good. Someone's asking for menu attendance. Let me knock it down. All right, so I hope all of you are actually doing well. And today's, I think before we start, I think we have two things. One is actually the project that you will have to work with your team member on the project. And from now onwards, every Saturday, we will be having this quiz session. We're having quiz, so you will have to sit for the quiz. And then for your information for your final exam, it will not cover all the learning unit. It will be covering the remaining learning unit that we haven't been testing you. Okay, that means the one that has been tested in your mid-semester exam will not come out. Will not be covered under your final exam. This means starting from learning unit number 7, then until learning unit number 13, that will be the scope of your final exam. Right, so I think the quiz is going to help you on your study as well, and then the quiz also carries some marks for your assessment, so please do not miss. And then the quiz is actually open one whole day, 24 hours. So you just need to free your time and then to just sit for it within that 24 hours period. All right, yeah, I think let's move on to our learning unit number 9, which is actually on data link layer, which is where we're going to talk about the data flow control today. And data flow control, in short, is basically controlling data flow, and then when there are errors or when to transfer. So this is actually how the flow of data is being controlled in the layer number 2. So these are all covered under the data link layers. Okay, so let me look at this. Okay, so if you look at this diagram here, it is not hard for you to see that, the data link layer is actually cover quite a number of services. And today we're going to talk about the packetizing. Packetizing means you have to group your data bits into groups so that it is easier for you to actually transmit instead of you sending them bit by bit, which is very hard for each of the station to actually recognize this data packet is for who. That's why packetizing of data is actually already happening in layer 2. Although layer 3 also will group data into packet as well, but you know that different layer, the way they're grouping data is different. So today we're going to talk about the packetizing, or more precisely, we call it the framing. The framing, we're creating data frame in layer 2. And it's one of the process of data packetizing. Right? So sometimes people use these words. This is English, the English. So the data packetizing process in layer 2 is called framing. And we're going to talk about it today. And we also talk about the flow control as well as the error, not the error control, it's a flow control. Let's talk about error control last week. So framing is actually one of the process of packetizing, grouping data bits into frame so that you can put address on each of the frame, and then you can send them according to frame. This means batch by batch. And so that you can actually, it's more efficient. You can put address so that because most of the data transmission are actually connectionless. That's why by having address, that it will be easy for each of the end station to recognize, this data packet is for who, and so on. So by grouping them together, this process is called packetizing. And then in layer 2, we call it framing. In layer 3, it's also got their own packetizing process, okay, where they produce data packets at layer 3. So this is layer 2. Just don't confuse. And framing, we will have two different types of framing. One is fixed size framing, and the other one is variable size framing. And from the name, I think it is very easy for you to differentiate. Fixed size framing, that means the frame size is fixed. And variable size framing, basically the size of the frame itself is variable depending on the amount of data or the type of data that you are sending. And of course, they have both pro and cons of fixed and variable size. So let's look at the details. And for fixed size framing, one of the example is ATM network. The ATM network is not asynchronous transfer. It's not the auto teller machine. It's actually asynchronous transfer mode. It's one of the advanced technologies that uses fixed size framing. This means each of the frame that's set up in this ATM network is actually of a fixed size. So it's not variable size. Most of our network, the non-ATM network, so the non-frame relay network, all the size, all the what we call the frame size, they are all variable. If you're actually using Ethernet, most of the time when you actually buy a switch, okay, you are running on Ethernet network. If you go to the shop and buy a switch and then you plug into your computers, most of the time, that network is actually an Ethernet network. So all the Ethernet network are running on variable size framing, okay, except for a special network like ATM, frame relay, they're all using fixed size framing. Of course, fixed size framing, they will have efficiency of achieving greater efficiency based on their own methods because they create virtual channel. You still remember they create virtual channel. That's why for fixed size framing like this, they do not have a very long address field. And most of the time, variable size framing, they will have longer address field. And because they, each of the frame can house more data bit. Okay? So they are actually much more flexible, but they are less efficient in terms of maintaining quality of service of the network. So these are just different network technology design. So we cannot say that which is better, which is lousier. And each of these network technology has got their own advantage. So you just have to use the right network at the right place. Okay, so you have to adopt the right type of network technology for the right purpose. Then that network technology will shine. Okay, you will be able to take full advantage of that particular scenario. So if you aiming for something, some network takes deliver very high requirement on the quality of service, then ATM networks that come with fixed size framing is actually very good because it is more consistent. It is can be able to get more guarantee better in terms of quality of service as compared to variable size framing, which is sometimes longer, sometimes shorter. So it may affect your overall network performance, right? So if you have a network that you think that quality of service is so important, then fixed size framing is a better choice. It's a better choice. But for most of our network, for example, the internet, they are not running on fixed size framing. Okay, the internet running on TCP/IP, they are running on variable size. And of course, TCP/IP is at layer 3. At layer 2, most of the people running Ethernet instead of ATM. So Ethernet network is actually variable size framing. So you will have, sometimes you get a larger frame, sometimes you get a smaller frame. But for ATM network, the frame is called a cell and they all come in the same size, right? So this is actually different. I just want to tell you that not to say fixed size is better than variable size, but they're both having a pro and cons. And of course, variable size is cheaper, right? And that is the way to go. And then variable size has been used in our Ethernet network and so on, which is a more common and cheaper networks. ATM network are actually quite expensive because they are proprietary, right? So for variable size framing, so as the name implies, the size is variable, sometimes
Sir,
longer, sometimes shorter.
excuse me, sir.
Yes.
Are you sharing your screen right now? Because we cannot see.
Oh, you do not see my screen. Okay, sorry.
Yeah.
Oh, sorry.
Yeah.
Gosh. So you hear me talking only. Sorry.
Yes.
Now you see something?
Yes, now we can.
Yeah, you should have told me earlier. That's why I say, I tend to make this kind of, because so many things to control. Yeah, you see? No matter how many times I did it, but I still make mistake. Okay, but never mind, it's okay. I think we haven't see any diagram yet. I think that is still quite okay. Okay, so you heard what I'm saying. All right, so for previously, we have this fixed size Okay, fixed size framing. So fixed size on ATM. So ATM network is actually one of the example with fixed size framing. And then now variable size Ethernet, okay, which is actually a more common type of network that we use every day. And now this one is actually the variable size framing, which is come with two different approaches. One is actually called the character-oriented approach, which is actually the byte-oriented type of framing, and the other one is actually bit-oriented type of framing. So from the name, you can tell, byte-oriented is always go by 1 byte, 2 byte, 3 byte, that of thing. So it's based on a smaller grouping, which is based on byte grouping. And then the bit-oriented approaches is actually very much based on the bit. You group the bits together, right? So example for byte-oriented type of approach is actually point-to-point framing protocol, PPP. If you actually get on the internet, most of the time you are actually connecting to the PPP using the PPP protocol, point-to-point protocol at the layer 2. And for bit-oriented approach, the example is HDLC. HDLC is very much a Cisco-based, Cisco proprietary type of protocols. So you know that Cisco is a big name in computer network. So a lot of equipments out there are actually running on Cisco equipment. That's why Cisco has got great influence in terms of the protocol that are being used, and HDLC is only supported by Cisco equipment. And because of there are so many Cisco equipment out there, that's why sometimes people have no choice, you just have to use HDLC. But if you have equipment that is other than Cisco, that you want to interconnect with Cisco equipment, then you cannot use HDLC because HDLC is not supported by other equipment manufacturer. Other equipment, for compatibility, most of the time they have to use PPP, okay, which is actually stand for point-to-point framing protocol, right? So I think just need to differentiate these two, and then these two are actually all in layer 2, right? Different manufacturer, different protocol, and then we have two different protocol to play with in general at layer 2. Right, so this is the byte-oriented protocol. I think just look at the diagram. So you can look at this is actually a frame. This is actually a frame of the protocol here. You can see on this frame here, you will have a header. You will have header, and then you will have a trailer. Okay, so the header and the trailer indicate the beginning and the end of a frame. So your frame is supposed to start from here and here. Okay, so this is actually the entire frame. And then in between, you will have others, data and information. It could have address and, all those things. Okay, inside this blue color box here. And because of frame, you have to send it, data has been sent it out frame by frame. So frame by frame, when we look at a picture like this, it's very easy for us to tell where is, which one is the beginning, which one is the header, which one is the trailer. But sometimes they get mixed up, you see, because from the signal level, everything is actually 1 and 0, 1 and 0, right? So your header come with a pattern. That's why in order for you to differentiate between one frame to another frame, we have to add the flag here, you see. The beginning, before the header, we add the flag. And towards the end, we add another flag. So the computer will be able to detect the flag, then to determine the beginning and the ending of a frame. So that will be easier, right? This is something like packaging, right? It's something like a packaging for the frame itself, so that it is easier, so that it will not mix up, right? If you can see, when you actually send data over the network, over the transmission media, they all come in 1 and 0. And your header is also made up of 1 and 0, So sometimes they can get mixed up. That's why they need to put the flag. Flag is actually a series of characters, a series of something like a special character that to allow you to differentiate whether this is a flag or this is the content of the frame. So if you can see how this thing happened, so you can see that flag is actually a sequence of, this flag here is actually a sequence of a sequence of bits. And then let's say this is 1, 1, 1, 0, let's say. Okay, so your flag here is also 1, 1, 1, 0. So every time when the computer detected 1110, so they know that, oh, this is a flag. after the flag here, this will be the header. And then when it detected again another 1110, this is the end. Okay, this is the end. So computer will only detect these two, the flag pattern. For example, 1110 is the flag pattern for this particular frame. Okay, so but the thing is, if let's say in between here, you see, here's a data pattern. This is data. Your data happen to be 1110 also. If your data happen to be 1110, then the computer might mistaken this part, this one as the end, So this is your data, but it's just somehow happened that it has the same pattern as the flag. So the computer might mistaken this one as the end of the frame. So in order to prevent this from happening, so they add another special character here just to differentiate, saying that if there's an escape character here, so the next one is not a flag. Okay, so every time when you see that it is not a flag. So this is how byte stuffing is being carried out. And for bit-oriented protocol, it's same thing here. You have the bit patterns here as well. So your flag come with a pattern as well. Now byte is actually can be a character, but at the end of the day, what the computer see is also 1 and 0. So this is actually the sequence, the ending sequence, the beginning and the ending sequence, 0, 1, 1, 1, 1, 1, 0. So this is actually the flag. So if anything happen in between here, inside your data also got the same pattern. So the computer can always easily mistaken this one as the ending sequence or a beginning sequence, whatever it is. So in order to prevent this from happening, so they have to use stuffing. Right? So when you use stuffing here, if you look at this one, this is also, 0, 1, 1, 1, 0 happening here. So, for you to actually prevent this from being accidentally recognized as a flag, so you will have to do stuff. So you put extra 2-bit here, okay, to make sure that it is not, it is not being recognized as the flag. Your data shouldn't be mistakenly recognized as a flag. That's why they use stuffing. So the whole purpose of stuffing is like that. So here I just explained to you the concept because it's harder for me to actually draw the things on the screen here. So I just explained to you the concept. The whole idea of stuffing is to make sure that the content is not being mistaken as the flag. All right, so flow control, error control. So once you have got a frame ready, so there's two things that we need to look at is actually flow control. Another one is also error control. How do we control errors? Because we all know that this error in the transmission line cannot be prevented. So we have two types of error control. Last week we talked about one type, which is actually once to detect error, then you drop the packet. It's for error detection, and then for error correction. And now we're talking about here is error control. How do you control, when error happen to the frame itself, then you are missing frame. When you're missing frame, so what will happen? So how should the system control this kind of error? This is talking about missing, especially missing or the frame that come with errors. All right, so flow control. Error control. In error control, we use automatic repeat request. So what is repeat request? It's actually, in short now, we just call it when you have a damaged frame that is being received by the receiver, so they will use this automatic repeat request to ask the sender to retransmit the frame again, the same frame again, to retransmit the same frame again. That's why we call it automatic repeat request. So the whole idea is to trigger the sender to resend the same data frame again. So this automatic repeat request ARQ is actually for this purpose. It's for error control. Okay, and of course it is actually a protocol. So let's look at the different protocol that has been used for different type of scenario. And we all know that we have two different types of scenario here. One is actually the noiseless channel, which is ideal channel. a channel without noise, so perfect, ideal, non-existent. This kind of channel, non-existent. So the more practical one is actually the noisy channel. So the noisy channel is more practical because all our channel come with noise. It's just different of magnitude. Some channel has got more noise, some channel less noise, things like that. And you still remember what is a channel? A channel can be a transmission, is referring to a transmission medium. Okay, if you are using UTP cable or you are using fiber optics transmission medium, so your channel will have less noise because that is cable. But if you are using a wireless transmission, then your wireless channel is going to have more noise. It's much more noisy, right? So that's why sometimes we use a lot of this term here. So I hope you understand what we talk about. When we talk about channel, it's actually about a transmission medium. So for noiseless channel, we use a very simple type of methods like the simplest and the stop and wait. And for the noisy channel, which is more practical, we use the automatic repeat request protocol. Like we have 3 different types: stop and wait, go back N, and selective repeat ARQ. And the 2 types is actually, for example, such as the go back N ARQ and the selective repeat ARQ. They are using a sliding window. Sliding window means that they are not doing it, bit by bit. They are doing it using grouping. They're using grouping. That's why it is called a sliding windows protocol. They do it in groups. If you can do things in group, most of the time it is more efficient. You can deliver more data rather than you receive 1, acknowledge 1, receive 2, acknowledge 2. Right? So that one will be too slow. So for performance matters, it is always to use transmit in group will be achieving higher efficiency. All right, let's look at the noiseless channel here. And we have the simplest algorithm protocol and the stop and wait protocol. So this is actually the design of the simplest protocol with no flow and error control, because you assume there is no error. You see, noiseless channel, but you see the channel is noiseless. That's why you do not experience error. So you just keep sending only lah. You just keep sending. The simplest one is just keep sending. There's nothing. Okay, this is actually the way lah. So just keep sending and the receiver just keep receiving. And for the stop and wait protocol, it's actually slightly more complicated. So after you send 1 data frame, you see, after you send 1 data frame, you will have to expect 1 acknowledgement frame as well. So the the receiver will send out another frame called the acknowledgement frame. ACK stands for acknowledgement. Right? You will send an acknowledgement frame back to the sender. What is this? What is the function of this acknowledgement frame? It's basically to tell the sender that, hey, I have received your data frame successfully without errors. No errors. Then I send acknowledgement frame. Everything received in perfect condition. Then I will send 1 acknowledgement frame. So for every data frame that has been received, the receiver will have to respond with an acknowledgement frame, sending to the sender. So this is what we call the simple stop and wait protocol. Okay, so these are actually the algorithm. So if you want to look at how it works, this is how it works. This is the time diagram. Okay? This is the time diagram. For every frame that is being sent, you will have an acknowledgement. Okay, the second frame, second acknowledgement. You send, receive, acknowledge. Then once you receive acknowledgement, then you send the next frame again, right? So this is actually a simple stop and wait protocol. So when you hear stop and wait, the simple one is actually to deal with a noiseless channel. That means there is no noise coming to the pictures. That means no noise means no damages to the data frame. And this kind of channel is non-existent. To be honest, even if you are running on fiber optics, there will be still certain small fraction of errors that could possibly happen to your channel. That's why the ideal channels of noiseless channel is non-existent. So let's look at the noisy channel, which is a more practical type of channel, because all the channel come with errors. It's just in different magnitude. Wireless channels will have a lot of errors, a lot of noise. A lot of noise means a lot of errors. And then fiber optics is the best, will have the least amount of noise, and then will experience the least amount of errors. And copper cable like UTP, coaxial cable, those are sit in between. But the amount of error is still considered less. But fiber is the best. So the channel that come with the most noise and the most error is actually the wireless channel. So for noisy channel, we have three different types of ARQ, okay, that we're going to talk about. And then the detail of these three different types of ARQ, I already have a separate video for these three different types of ARQ to explain to you on a separate video. And then this video, I just make them available in Ellipse. So you can go to our Ellipse page, the lower section. So I have these three different types: stop and wait ARQ, go back N ARQ, selective repeat ARQ. These three different types of ARQ have their own separate explanation video, right, to help you to understand how they work. But the whole idea here is to deal with errors. That's why it is called the automatic repeat request. So if anything happens, the sender is going to repeat the request by sending the same data frame again. So that's the whole purpose. So the main purpose, you don't get confused. Once you get clear with the main purpose, I think the rest is going to be easy. So now with an enhanced stop and wait ARQ, what do we have? So we will have this. This is the normal operation where everything is perfect. So you send, the other one send you acknowledgement, you send the remaining frame, send acknowledgement again. But when your frame got lost, okay, when your frame got lost, there is no acknowledgement will be received by the sender. So the sender will have to wait this amount of time, okay, the sender will have to wait this amount of time, basically from here, okay, from here until here, this is the time. Okay, there is a fixed timer. They have to wait. The sender, after they send out the frame, they wait for the timer. So within that timer, they have to receive the acknowledgement. So if they do not receive the acknowledgement, what they are going to do is this sender is going to retransmit the same frame again. Okay, for example, you look at this diagram here, frame 1 that is being sent out, and then it got lost, you see. Frame 1 got lost. So there is no acknowledgement sent from the receiver. So after waited for some time, then the sender realized that something is wrong. Maybe the frame is got lost or it has been damaged. So it will send again frame 1. See, you can see that the frame 1 has been sent 2 times here. Okay? Because of the first sending of frame 1 do not receive, they do not receive an acknowledgement from the receiver. That's why they wait for a certain time. The time lapse, they will resend frame 1 again. But this time, they receive an acknowledgement. So when they receive an acknowledgement, that means the transmission is complete. Right? So the whole idea is like this. Okay? Is whenever there is a loss, so the other side will automatically retransmit. And then the same thing can happen to the transmission to the acknowledgement frame as well. You see, this is the acknowledgement frame for frame number 1, but it got lost halfway. You see, it got lost halfway. So it's the acknowledgement frame lost. It is not the actual frame lost. But to the computers, to the sender do not understand, they do not care whether which one is lost. As long as they do not receive an acknowledgement, then they are going to retransmit the same frame again. You see, this is frame 1. So you are going to retransmit frame 1, even though it is not the frame having problem. It's just the acknowledgement frame having problem, but that will also trigger automatically a repeat request. Right, so it is not necessary has to be the data frame get into trouble, got error. But if your acknowledgement frame go into error, then you will still have the same mechanism happen. Okay. So the same thing happened to delay as well. And then the design, it's there's a timer. The design is just added a timer. Okay. So when you send, then with a timer, waiting for acknowledgement. No acknowledgement, you are going to retransmit again. As simple as that. That's why I said the details. I want you to look at the video if you still cannot understand fully. So I really want you to look at the video if you need the video in ellipse. I just pause for each of the ARQ, the lower section, the lower sections on the main page. So these are actually the pseudocodes for the ARQ, the stop and wait ARQ. So these are actually the calculations. So this example, I just want you to go through. Right? It's actually quite useful. So the only problem with this stop and wait ARQ is that it's only doing one frame at a time. Every time you send one frame, they will keep waiting there. They are not doing anything until they are waiting for what? Waiting for the acknowledgement frame to arrive. So it's actually a waste of time while they wait, right? So it's not so efficient. So while you're waiting, you can also do something else, right? So that's why I say when you actually wait for your bus to come at the bus station, what are you going to do? Are you going to just, not doing anything? Some of the students will just take out the book and then start to reading some books. So this is actually more efficient, better time management, isn't it? So the same thing happened here. The simple stop and watch ARQ is not too efficient because every time you send one frame, then you must wait for that frame's acknowledgement to come back before you send the second frame. Okay, if the waiting time is a waste. That's why people are not so happy with the simple stop and wait ARQ. So people introduce two new protocol, which is actually the go back N ARQ and the selective repeat ARQ. Okay, go back N. The name will tell you. Just now I already told you that sending one frame at a time is not efficient. So what are they going to do? What the sender going to do is to send a series of frame. Okay, a series of frame all together, and then you wait for the acknowledgement. It's actually doing in batch doing in group instead of just doing individually one by one. But now you do it in group. So you send 5, or let's say now you send 5. After you send 5, only you start to wait for acknowledgement. The one that you do not receive acknowledgement, then you will actually send them, trigger the retransmission to actually send one more time. But you are not going to send all 5. Okay, so this is actually the principle. And each of these frame has got this thing called a sequence number. Okay, inside the header, there is this thing called a sequence number inside. So through the sequence number, they know that this is frame number what? Frame number 1, frame number 2, frame number 3, frame number 4. So it's all go by the sequence number, which sit inside the header. Header has got a lot of different information. One of the information is actually the sequence number. Okay, they got many fields. One of the field is actually sequence numbers. So based on sequence number, you will be able to use this go back N ARQ to allow you to send multiple frame at the same time and without mix up them, because each of these frame is identified by their sequence number. Okay, so different frame, different sequence number, so they know how to put them together, and then to tell which frame has got lost based on their sequence number. Okay, so these are actually the sequence number. So I'm not going to talk about sequence number, but I just want to deliver you the concept. And for this kind of protocol, they are actually using the cumulative acknowledgements, okay? Because they are receiving multiple frame. And now when something happen, I just want to tell you, when something happen, they are going to go back to N. If everything here is okay, if you look at this one, it's okay. This part is okay. So this part will not be retransmitted. So until the errors occurs. Let's look at the errors. I think it's actually harder for me to just explain like this. I think if I have animation, then it will be easier. That's why I say I included additional videos for this 3 ARQ protocol. So I will really need you to look at them if you do not really get the idea. But one thing I want to highlight to you, the principle, the design principle of this go back N ARQ is that you first transmit a group of frame to the receiver. Then after that, you wait for the acknowledgement. Instead of you do it one by one, you send one, they acknowledge one. You send after acknowledge, then you send number two, then you wait for acknowledgement again. But this time you know. You continuously send a few, only after that you wait for the ARQ. So the overall throughput of the network by using this go back N ARQ is going to be higher because you can send more, you see. You don't always wait for the ARQ, you know, after you send one frame, but now you send multiple frames. After you finish multiple frame sending, then you wait for the ARQ. Those ARQ that is not received, then you retransmit. Okay, you retransmit them. And then because you are doing it in batch, you do it in batch. That's why you cannot transmit individual. You also have to transmit it in a group. So where are the errors start? Okay, you have to identify where are the errors start, which frames start to have errors, then they will start to retransmit from that frame again, from that particular frame, retransmit. And so if you are sending all this frame here, then suddenly the error start here. Let's say this is 1, 2, 3, 4, 5, 6, 6 frame. Let's say this one got error. So the retransmission will only start from here. 1, 2, 3, 4, 5, 6. Okay. So you will be transmitting this one only. And because your 6 has got problem. Your 6 has got problem. So you will retransmit from this point. So the one in front, 1, 2, and 3 will not be retransmitted. So it's basically just like that, lah. I mean, the overall concept. Okay, so everything is the same, except that, you know, it's allowed to transmit a group of frame rather than just one frame at a time. Now you can transmit a group of frame. So that is straightforward, more efficient. And the window size is actually based on 2 power of n minus 1. So this is actually how the protocol works, lah. So they're based on 2 power of n. So I guess the video lectures, I mean, not the video lectures, the video explain, the additional video explain is actually very helpful. Okay? It's very helpful because they come with animation. You can actually understand better than just listening to me describing the situation. But what I can tell you here is actually the principle of each of these design principle of each of these protocols. So I'm going to skip all this. Okay, now let's compare the go back N ARQ and the stop and wait ARQ. The stop and wait is the simple one. Okay, if you can see that the stop and wait ARQ is a special case of the go back N ARQ with the window size of 1. So they go by window size. And this means they can transmit multiple frame at the same time. You know, so in one time, they can transmit multiple frame in one time so that they can make good use of the available bandwidth. And this side of transmission is particularly good for long round trip network. For example, a satellite network with very long round trip time, RTT. So it will actually increase the efficiency of the bandwidth utilization because you don't wait one by one. You know the long network, the waiting is very long. That's why you don't want to just wait. You want to send them one group, then you only after you send, only you start to wait. Right? So they will be much more efficient, especially for network with long round trip time, such as satellite network. Okay, so there are also problems as well. Not to say that this go back N ARQ is actually very good. It also comes with its shortcoming. So in a noisy link, a frame has a higher probability of damage, which means that the resending of multiple frame. So because it's sending multiple frame, depending on where the error occurs, see, that's why you need to start to retransmit from that error. You still do it in groups, but this retransmission also come in group as well. That's why it's not too efficient as well if you have a very high error link. This style of go back N ARQ may not be as efficient. That's why people propose a selective repeat, which does not resend N frame when just one frame is damaged. Only the damaged frame is resent. So this is more clever. You will be able to know exactly which frame is actually damaged. So you will just retransmit that particular damaged frame only instead of transmit the whole group. Before this, go back N is the whole group. Okay, starting from this point, then one group of frame will be retransmitted. So this is actually more clever way, selective repeat ARQ. So again, same thing here. If you do not really get the idea of how this selective repeat ARQ works, then we have videos. We have video in Ellipse. You can always look at them and watch them because they have animation which can actually make you understand easier. I mean, thanks to technologies. Last time I had to draw it on a whiteboard, but now this is online. So drawing on a whiteboard is actually much harder for me to accomplish. So I think with the help of video animation, I think that will really help you a lot in this in understanding the differences of this ARQ. So they use this selective repeat. They use a negative acknowledgement. Okay, and acknowledgement has got two different types. Okay? One is called a positive acknowledgement. The other one is called a negative acknowledgement. So negative acknowledgement is what? What's the difference? A standard acknowledgement is a positive one. Positive means when you receive something, everything perfect, then you send out acknowledgement, telling the sender, hey, everything is okay. So this is positive because everything is okay. Yeah? Everything is received perfectly. Then you send acknowledgement to tell the sender everything is okay. But if you only have a very minor set of networks problem, only a few frame has got problem only, then most of the time you will be sending positive. You will be sending a lot of positive acknowledgement frame. So in order to reduce the amount of positive acknowledgement frame, then you can just send negative acknowledgement. So those frames that are received successfully without errors, you don't send acknowledgement, but you only send negative acknowledgement when that particular frame is damaged. The one that is damaged, then you inform. And this kind of acknowledgement is what we call negative acknowledgement. And it is represented by NAK. You can see that. NAK compared to ACK. ACK is a positive acknowledgement. NAK is a negative acknowledgement. Right? So you must understand the differences between the two. Sometimes when you have a very reliable transmission line, most of the time your data packets are okay, only one or two not okay once in a while. So it is not too clever to always send acknowledgement frame because your network will be full of acknowledgement frame, because all of them are good, you see. So it will be more meaningful to tell the sender, hey, these are the ones that has got problem. So you just need to resend some of this on it. That's why by sending a negative acknowledgement, sometimes it can be more efficient. Okay, for a network that with lower error rate. So that's why I say, it's which protocol is to be used is really very much depending on what kind of transmission medium that you are dealing with. So this ARQ, this selective repeat ARQ is very good. It's going to be very good for fiber optic side of transmission medium because fiber optics pick up very little error. So this is going to be very effective. So if you are using this selective repeat ARQ on a wireless network, so that is not too clever because, wireless network tends to have a lot of errors. And then, you're going to send a lot of negative acknowledgement as well. So that is not too efficient. So there's really, that's why I said people need to come up with so many different type of ARQ technique. It's because of to accommodate different type of scenario, different type of situations. For example, the go back N is very good for, high latency network. Yes. And then for the selective repeat request, selective repeat ARQ is very good for network with very little error, right? So that they do not need to waste a lot of ARQ packet, ARQ frame to send it back to the sender. So I'm just telling you the overall concept. So you want to know the detail, I think it is better for you to just look at the explain video. The additional reference explain video that I put inside Elite. You can watch them. I think they are doing a better explanation with all the animations around. So these are actually some of the diagram. I think I believe I have explained this in my lecture video. Some can be quite complicated. Like maybe you have to go through the time diagram one by one. Then you trace them. Then you will get, oh, it's actually indicating the same concept. And these are the algorithms. These are the programming algorithm. How do you implement the protocols? So I said all the protocol are basically software programs. So you can just write your own protocol. So I will not go through some of these. So example, you really need to go through them. And the diagram, I think I will just leave it. This diagram is really here to follow closely. But just look at the video with animation. That will actually very good. Okay, and if you look at this one, this is actually we look at link layer technologies. Right, you know that we have different protocol here. Okay, and for wide area network, usually they use different type of link layer technologies. For example, the common one are HDLC and PPP. And frame relay are a bit older. It's actually the grandfather of ATM network. Okay? Frame relay is grandfather of ATM network. So before ATM network was born, people were using frame relay. And frame relay share quite a lot of similar characteristics as the ATM network. So they are also using cell relay as well. So it's called frame relay. And then today's we will have expanding our Ethernet. You know, we all know that Ethernet technology has been used for local area network only. Okay, and then people has been expanding the Ethernet into a carrier grade that of Ethernet. They call it the Metro Ethernet. So you allow a long distance connection. You allow a long distance connection using the same Ethernet technology. And this thing, I think our operators like TM are actually using it for their corporate customer. Right? So they are using this Metro Ethernet. So let's look at some of this protocol here with some brief introduction. HDLC, very much used in what we call the Cisco type of equipment. And this HDLC is actually implementing the ARQ mechanism that we discussed in this learning unit. So HDLC comes in two different transfer mode. One is the normal response mode. The other one is asynchronous balance mode. Okay, let's look at the difference. The normal transfer response mode is actually, you know, the primary station can only send command, secondary can only respond. So they're actually easy. So primary send command, secondary only can do respond. So secondary cannot send command. Right? So the primary send command, secondary respond. But this is actually the normal response mode. As for the ABM, which is actually stand for the asynchronous balance mode. So the asynchronous balance mode is actually allowing both primary and secondary to be able to send command and respond at the same time. Okay, so this is much more complicated. This is much more comprehensive. And in terms of HDLC, they also come in frame. HDLC is a layer 2 protocol. Okay, one of the layer 2 protocol. Okay, just don't get it confused now. Okay, our 7 layers, these are just general name. So each of the layer will have their own implementation. For example, your Ethernet is actually one type of data link layer protocol. And your ATM is also another type of layer 2 protocol. And HDLC is also another type. Right? And then PPP is another type again. And that's why, to be honest with you, layer 2 protocol is actually quite complicated. They have a lot. So all your LAN, they got the LAN protocol, MAN protocol, you know, LAN, MAN, WAN, you know, local area network, metropolitan area network, and wide area network. So different type of network, they use different type of protocol at layer 2. So you want to look at the most complicated layers, it's actually layer 1 and layer 2. Layer 1 and Layer 2 is so sophisticated. There's so much of network technology involved in these two layers, especially a lot of protocol in Layer 2. Layer 1 is very much the transmission medium. You know, what kind of transmission medium we are using. Are you using copper, coaxial, wireless, fiber optics? Those are in Layer 1. So those are dealing with signaling. Okay, all the signal, electrical signal, light source signal. But for Layer 2, we are dealing with all the protocols here. Okay, all the protocols. There are so many different types of protocol. As the time passes by, new protocol will be introduced. A more efficient new protocol will be introduced, and the older protocol will be obsolete, such as frame relay. Frame relay was quite popular back in the 80s and in the 90s. Okay, and then but now because there are better ones, such as ATM. ATM has been offered a better service as compared to frame relay. Then the frame relay will start to get extinction and become extinct, and people will be using more on ATM. But again, ATM protocol is again proprietary. They are expensive as well. So people think that maybe I do not need all the features offered by ATM. So I will just go with the cheaper Ethernet. So that's why nowadays, all the switches, all the network adapter that you are buying from the market are all majority, I would say, more than 90% are actually using the Ethernet protocol. Ethernet. ETHERNET, Ethernet. Right? So they are not running on all this HDLC. These are all for a more wide area type of implementation. Ethernet is actually mainly used for local area. Ethernet. So when you buy a switch from the shop, or when you buy a router, your home Wi-Fi routers from the shop, they are all based on Ethernet. And each of these protocol come with their own different type of frame. Like for example, HDLC come with 3 different type of frame. They got I frame, S frame, and U frame. Okay, the I frame, S frame, and U frame. Obviously, each of these frame will actually serve a different type of function. Information frame is used to carry data. Okay, the name tell you that I frame, I stand for information. Information frame is used to carry data, and supervisory frame, S frame, is used to transport the control information. Okay, for networks control, they need to exchange control information, so they're using S frame. And there's another type called the unnumbered frame. Okay, U frame is actually mainly used reserved for system management. So U frame is hardly used. So most of the time it's I frame and S frame. So these are the different frame format for each of the frame. Obviously, I frame is going to be longer than the S frame, right? Because your user information here is going to be a lot. Your user information is a lot. This is your user information. Your information will be put inside this field called the user information. But for S frame, is used for supervisory, is used for control. So they do not have a frame for user information. Right? They don't have that. That's why they are shorter. As for the unnumbered frame, then you will have the management information. So sometimes management information can be quite a lot as well. Okay, so it will be longer. And the frame format, that's why they have a different sequence flag. They're also using flag. Okay, their flag will have different sequence, and they also have address inside the header, things like that. It's pretty standard. And also they have a control field as well, information field, frame check sequence field. Okay, so what is frame check sequence field? Is actually the field allow you to do error detection. This frame check sequence field is the one that you can use it for error detection. And information field, the name tell you, is for user data, and control field is for sending control information, such as flow control or error control. So these are the control field format. So I will not talk too much about this, because we don't want to go too deep into the subject matter. So the control field will have all this information inside there. And then for S frame, the control field is slightly different. And the U frame control field also slightly different. They serve different functions. Basically, the control field will decide what kind of frame is this. Okay, based on the information in the control field, they will be able to differentiate. So, all right, so let's look at all these example here. And I think you just need to understand the concepts. Okay, each of these data link layer is actually a layer where you can have different type of protocol. This is what we call the data link layer protocol. And you have different type of protocol for different kind of network. We all understand that we have local area network. It's the smallest network, right? Local area network. We have metropolitan area network, which is for the city. And we have wide area network, which is for countrywide or even for across country, or multinational. And these are all private owner. Remember, all these three type of network has got only one single owner, private owner. This is not the internet. No, the internet is not a wide area network. But even though it looks so wide, but it is not owned by one single organization. Because it is not owned by one single organization, they do not fall under the category of wide area network. So we have these three category of network: LAN, MAN, and WAN. So each of these network will have their own data link layer protocol. Different type of data link layer protocol serve different type of network. For example, local area network, we have Ethernet protocol, which is the most popular one. Ethernet protocol that you are using it every day. And for metropolitan and the wide area network, they are very much similar because they are already wide area, they are already quite large network. So metropolitan area network and wide area network, usually they share some of this protocol. They use a similar type of protocol, such as HDLC, such as PPP, those are the protocol that has been used for metropolitan area and wide area networks. So that's why I just don't want you to confuse. So the whole idea for me to explain this is to get you to clear about the protocol and then the different category. And of course, each of the protocol, they behave differently. And they're also having different frame format. Okay? Different protocol will have different frame format. The example that we have just discussed is HDLC. HDLC has got three different type of frame. Okay, I frame, S frame, and U frame. See, but if you look at different protocol again, they will have different type of frame again, you see. That's why I say all these frame depending on the type of protocol. Right, so now we talk about point-to-point protocol, which is different from HDLC. Right, so this is actually a different type of protocol. This is actually a byte-oriented protocol. HDLC is a bit-oriented. So let's look at the details of PPP protocol. This one is quite common. If you are connecting to the internet using your Unify, Maxis Fiber, okay, so they are all using, such as your Streamix, they are all using the PPP protocol. PPP protocol. They are not using HDLC. HDLC is a proprietary to Cisco equipment, unless you are running Cisco equipment. So it's only allowed Cisco device to talk to Cisco device only. So Cisco device talking to other non-Cisco device, they cannot use HDLC because only Cisco device support HDLC. So that's why point-to-point protocol has become more popular. Okay? PPP has become more popular among the internet service provider because internet service provider have to connect you over a wide network, such as over telephone networks. So service by PPP, let's look at the differences. So PPP does not offer a flow control. So it is actually a simpler mechanism, okay? A simpler protocol that offer very simple error control, do not provide sophisticated addressing mechanism. Okay, so if you compare the PPP to HDLC, this PPP will also offer additional features such as link quality management that is not available on HDLC. But of course, I think HDLC is of higher performance as compared to PPP. It's just PPP is much more compatible. To a wide range of equipment rather than HDLC, which is very much specific to Cisco equipment. And then Cisco is actually the big brothers of network equipment. a lot of operators are actually using their equipment, and of course, one of the most reliable network equipment, and of course, one of the most expensive network equipment as well. And it's a very well-known brand, but there are others, manufacturers offering a similar type of service. It's just that maybe Cisco will have more advanced features as compared to some of those. Right. That's why, in terms of cost, of course, Cisco is much, much, much more expensive as compared to some of the other manufacturers. That's why it's really very expensive. Because can you imagine a switch, a 24-port switch can cost up to like 50,000 ringgit for one switch only. And then you can get a switch from the shop for like maybe just a few hundred ringgits. Right? Comparing a few hundred ringgits to 50,000 ringgits, which is you can actually buy a car already. So that is the kind of difference in terms of pricing. But of course, they are the very established brand name, reliable equipment, dependable equipment. So those are actually the advantage of Cisco. And Unimas used to be using Cisco equipment, but now we slowly migrate to others, non-Cisco, because Cisco is really very expensive to maintain. When our new campus was started, we are actually using all Cisco equipment. But I think after some time, if you want to go for the maintenance, it's costing a lot of money. And also at the same time, there are a lot of other equipment manufacturer offering services that are actually comparable to Cisco. That's why a lot of people also slowly move away from Cisco because of Cisco is just too costly, just too expensive. No doubt they are very reliable equipment. Okay, now you look at this frame format of PPP. You see, compared to what you have seen for the HDLC, then you can see this is different. You see, slightly the arrangement different. You see, this is actually the format used by PPP. Then they're also having flag as well, same thing, but the flag sequence is different. The flag sequence is different. They're also having a control field. They're also having address field. They're also having payload. Now, payload is your data. Payload is your data. Okay, payload is data. Okay, and so on. So these are the transition phases of this protocol. I don't think we want to discuss this. Okay. And multiplexing is the PPP. So you know that multiplexing allow us to send more data inside the protocol. So we have allowed the support of the following protocol, like the link control protocol, authentication protocol, network control protocol. So we can allow multiple protocol to be grouped together. So this is also that is also why PPP are more popular as compared to HDLC. Right. So depending on the type of payload here, this is the payload. So this is actually the payload that they are sending. They can send normal data or they can send other protocol data inside there as well. So I will not talk too much about all this. This one is getting more and more details. So it's probably harder for you to digest just by using one slide. You see. So actually, a lot of information. If you come across this course, you see a lot of learning unit are actually focusing on layer 1 and layer 2. Layer 1 and layer 2 has got the most information that you need to deal with. It's probably the most complicated layers. Layer 1 and layer 2. Then as you go up the layers, it will become getting lighter, getting simpler now. Right? So the hardest, if you talk about network technologies, this is actually layer 1 and layer 2 is the most complicated. All right, so I think I highlight most of the important points of this learning unit here. So we are talking about the layer 2. Layer 2 come with a lot of different functionality that we have to use a few learning units to actually cover all of them. But of course, it is not limited. All the protocol that we cover here are just for learning purposes. There are more advanced protocol out there that we do not cover in our learning unit. That's why do not mistaken this. Now what we cover is everything about layer 2, all everything is here. No, we are just showing you some of the standard mechanism in this particular layer 2 and what are the popular one, okay, that has been used for layer 2. Right, so it's actually a huge study, to be honest. Layer 1, layer 2, a huge amount of knowledge that you need to acquire. That's why this is the hardest part. And then when you go up to layer 3, life is very much simpler. Because layer 3 is based on the same concept, but they are much more simpler as compared to others network, others layer. Layer 2, because they need to take into account of a lot of factors like errors, like, distance, like delay, that's why they will have a lot of different protocol. And then the size of the network also affect the layer 2 implementation. That's why layer 2 has the most sophisticated protocol matrix. All right, so I hope this one can actually bring you, link everything together that you have learned previously, or for layer 2, all linked together, and you will see the bigger pictures. And each of these individual technique, how they work. So I will leave it to you. I will leave it to the video, the reference video that I put in, the additional reference video in Ellipse for you to look through and watch through, and then that will the animation will really help you to understand better than I just explain using my words. Sometimes you just don't catch what I'm talking about. That is actually quite tough. If I have a whiteboard here, then I can freely just draw the things easier. Yeah, I think someone raised their hand, got something to ask. But okay. Yeah, any questions? I think we are coming towards the end of our learning unit discussion, which actually I highlighted some of the overview. I think the overview is very important because that link all your knowledge together. That some of the learning material are actually very specific. Sometimes you got lost inside the the messy detail, but I just want to bring you back to the overall understanding that you will see where are those techniques sit in a particular layers. I know so layer 2 is the hardest, to be honest. Layer 2 is the hardest. There's so much technologies from last time until today. There's so much evolution of technology in layer 2. And layer 1, I don't see so much, you see, because layer 1 are very, very much physical. And this physical thingy, we have limited number of transmission mediums. But layer 2 also play a role of, medium access control, who can use the medium, whose turn and all those things. And then all this mechanism on how to deal with errors and how to deal with flaw, and then how to deal with, how do you packet them, and all those things are actually just the hardest. But I think that's why I say I want you to get a concept. And some of the important one that we are covered in the learning unit, you have to know because it will be coming up in the exam. You see? So I'm not saying that you have to explore, going a lot more outside from this scope. But I know the scope of this subject is actually quite huge. Okay? It's actually quite huge. It's probably one of the hardest subjects among all the other subjects. And then computer network has a longer history than computer science. Is it? Computer network is not, I would say communication network has a longer history than computer science. Communication network has more than 100 years of history, and computer science probably like 60 years. Okay? Computers has been born just like 60 years ago. Not too long. And that's why communication is very complicated. And back in the 1980s, the 70s, people start to combine computer science and communication network together, and they give birth to the computer network. And today evolve into the world's most important networks like the internet. That's why there's a lot of overlapping, a lot of sharing technologies between the communication technologies and the computer science. So that's why I just want you to get it clear. You have to make it clear, get the overall picture. The overall picture has to be clear. Because sometimes people study so many techniques, they don't know where this technique sit, where is this one come from, where is this one to do with the other one. So they get confused. That's why they cannot remember. You cannot remember because you are blur about what you are studying. So the overall picture is very important. You get the overall picture clear, and you know exactly what you are dealing with. So use a mind map to help you to link all those things together. I know it is quite messy, but that is the way of life. You just probably what we call your time and my time. During my time, I will probably learn a bit less. During your time, because as time pass by, 20 years of difference, then you have to pick up much more knowledge. During my time, people do not so much care about the internet, you see. During my time, people talk about the data network, but they don't care so much about the internet, because during that time, the internet had got not much thing in the internet, If compared to today's, the internet has evolved so much, so far away compared to last time. That's why don't blame anyone. It's just that, when you come later, you have to learn more. There's more thing for you to learn. So you can see that as an advantage, like you will learn more as compared to us last time. We have less thing to learn. Yeah. Okay. Is there any other questions before we call it a day? I will stop sharing. So I will look at your message. You want to talk about the group projects. We need to include the price for each of the network components. Okay, the price is just a relative. You can do some price indication. This means you will have the advantage to show that, okay, my design is more cost effective. Okay, you can show price or cost indication as a justification for your design. That is good, but not the exact pricing, just some estimate pricing. Just estimate pricing to justify that, you see, if my design will actually cost less. Okay, so this will be your explanation and justification for your design. You can always you see, my design is better. Why? Because my design is cheaper, it's more simple, cheaper. My design is more higher performance. So those are the justification where you can always justify your design, why your design is better than the others. Okay? So the question that your friend is asking is really like, you can use pricing, but just estimated pricing to justify your network design to solve that particular office situation. Yeah. So, and then again, for all of you here, I mean, group work is actually very important. That's why you really have to take your effort to participate in the group work. So if you do not change your, if you still, try to run away from your group participation, that thing, then that is very bad. Then you won't learn much. See. So, taking this opportunity, since you already enroll in courses in university, you have to really take this good opportunity to, to collaborate with others, learn the skill on how to collaborate with others. Because later, when you go out to the workforce, that is one of the most important skills. How do you work in a group, you see? So you're going to be attached to a group of people, and then all of you will have to work together. And then so if you cannot, blend in well with others, then I think it's very difficult for you to stay in the company. Right? So that's why take this good opportunity as an exercise for you to learn how to collaborate. And then a group project like this is a golden opportunities okay? On how do you work together and then produce one good piece of work. It is not so much about the marks, but it's actually how much do you gain, you personally gain from this grouping exercise. So if you have a lot of if you gain a lot, then later this is just an exercise. So you will be better off when you actually join the workforce later on. So coming to university is not just become a bookworm. See? So the human interaction and making friends is very important. I always advise students, you really need to have the campus life. Hopefully next semester all of you can just come back here to enjoy your campus life. And it's very important, see, because your friends today, 10 to 20 years from now, you will see your human network. This is not computer network. This is human networks. Who you know, all your friends go around the countries. It is going to be helping you in your career, in anything that you are doing. So this is your network that you are establishing, the human network that you are establishing. So who you know, you must at least know all your classmates. To establish this. So what to remember from the university life is actually all your friends. So it's not just the knowledge that you're picking up along the way. It's actually the relationship, the human, the human network that you are building, because all your friends coming from all over the country. Some of them are coming from overseas as well. So you are establishing the human networks that is going to help you in the next 10 to 20 years to come. So I don't always stay in your room, or just stay silent, just focusing on these materials only. But you really have to interact more with a lot of your friends, classmates, and join a lot of other social activities, club, and other stuff. That is definitely going to make you a stronger candidate in the futures, because all of you will become the executive level. When you go out there, you need to lead. You need to lead. You are not following instruction anymore. See, you need to have your idea. You need to be able to express your idea. You must be able to present your idea. You must be able to discuss your idea. See. So those are actually the quality that a graduate should have. You see. That's why I don't want you to just follow instructions. I want to see your idea. I want to see what are the new things that you can come up with. The less instruction I give it to you, the better, because they will give you freedom to be more creative, and they will not limit your thinking. They will not limit your creativity. That's why I think take all these opportunities. All the courses is the same. Okay, every exercise given to you is an opportunity for you to explore new things. You are not just learning fixed knowledge. What your lecturer can teach you is kind of limited, because our interaction time is limited. But what you can gain is actually exploration of new knowledge beyond what you have studied. The lecturer can only give you the guide, the hints of what is there. But to go the extra mile, you still need to acquire the skill on how to self-learn. Because when you actually leave the universities, who is going to teach you again? You have to teach yourself, you see. So there will be new knowledge keep coming in, you see. So if you do not acquire this new skill of on how to self-learn, self-acquired knowledge, which is actually through assignments, through knowledge exploration, then how are you going to survive for the next 10 to 20 years? You see, so if you want to continue to stay in this field, then your skill of learning new knowledge is very important. No one can learn everything in the universities. The university cannot teach you everything, but the skill of learning new knowledge, you have to bring this home with you, so that no matter new knowledge that you encounter, you can just acquire them in a few days, okay, or in a few hours. Then you will be able to, do your job well. So that is actually very important. That is actually the quality of a graduate today. You see. So you have a lot of technology to deal with, and there's so much knowledge out there. You see. So you don't just want to stop here. That's why you really need to explore. University is a place for you to explore. You see. So this is not like school. You have a fixed textbook. A fixed textbook, everything go according to syllabus. No, we don't want you to go we don't want you to be limited by the syllabus. We want you to go beyond that. Okay? Okay, so is there, yeah, those are my advice. So is there anything that you want to ask? So maybe I share the attendance again. Oops, I think there's one more here. Okay. So if there's no other questions, so if you have no other question to ask, then we will call it a day. If you have done your attendance, then that's it. So we'll see each other again next week. But on Saturday, please don't forget about you will have a quiz to attend to. All right. Thank you very much. So I'll see you again next week. Bye bye.